This question is from GATE 2015 Mechanical Engineering paper, set 2, question number 6. A small ball of mass 1 kg moving with a velocity of 12 meter per second undergoes a direct central impact with a stationary ball of mass 2 kg. The impact is perfectly elastic. Speed in meter per second of 2 kg mass ball after the impact will be dash. Let's write the given things. Let the moving ball be ball 1. So we have mass of the ball 1 is 1 kg. Its initial velocity u1 is 12 meter per second. Let the stationary ball be ball 2. So we have mass of the ball 2 is 2 kgs. Because it is stationary, its initial velocity u2 is 0. We have to find out the final velocity of stationary ball, that is v2. Now first thing, we can equate the final momentum to the initial momentum of the system. Initial momentum of the system will be m1 u1 plus m2 u2. It will be equal to the final momentum by conservation of momentum law, that is m1 v1 plus m2 v2. Let's put the values. We have m1 as 1, u1 as 12, so 1 into 12 is 12 plus 2 into 0 gives 0 is equal to m1 is 1 kg, so it becomes v1 plus m2 is 2 kg, so it is 2v2. So we have one equation handy here, 2v2 plus v1 is equal to 12. Let this be equation 1. Now we will need one more equation to solve the two unknowns here. Second equation that we can fetch is from coefficient of restitution, E. Coefficient of restitution, E, for a perfectly elastic collision is 1. And by definition, it is given as velocity of separation, that is relative velocity of after separation, divided by velocity of approach, that is relative velocity between the balls before the collision. So relative velocity after the collision is v2 minus v1. Now velocity of approach will be calculated with respect to moving mass. So it is u1 minus u2. This is equal to 1. It is already given equal to 1. So we can write v2 minus v1 is equal to u1 minus u2. Putting the values, we have v2 minus v1 is equal to u1 is 12, u2 is 0. So this is our second equation. The first equation was 2v2 plus v1 is equal to 12. Now we can add these two in order to find out v2 first. So when adding, this term goes to 0 minus v1 plus v1. In the first, here we get v2 plus 2v2 as 3v2 is equal to 12 plus 12 is 24. So solving this further, we have v2 is equal to 24 by 3, that is 8 meter per second. Let's fill in the answer. Speed in meter per second of 2 kg mass ball after the impact will be 8 meter per second. To learn more about impact and collision problems, you can refer to the NPTEL video Impact and Collision CH22 from the subject Physics for class 11th by Professor Sanjeev Sange. He is from IIT Delhi. I hope this solution will help you clear your doubt. Thank you.